Now that we can plot points on a coordinate plane, we're going to look at graphing equations. As I mentioned, there are a variety of ways to graph linear equations, and we are going to look at a few of those in this chapter. But we are starting today with graphing using a table. So I've kind of lined out 5 steps for you for doing this. Step 1, you're going to choose 5 reasonable x values for your equation. And I put reasonable here because um, there's no way that I can say these 5 points will work for every equation, because some equations will be centered differently on the coordinate plane than others. For example, one line might be here, where another line might be over here. We might have a line over here. We never know really where lines might be on a coordinate plane. And so if I tell you to use points that are over here versus points over here versus there's no 5 points that I can just say always use these points. And so I just tell you 5 reasonable ones. I will give you 5 to start with, and then you'll have to use your judgment to make adjustments as needed. Step 2 is to calculate your y values. So once you have your 5x values, those x values are values you choose. Once you choose your x, you'll use your equation to find y, because we know y is equal to some relationship with x. So if I choose x and I do whatever these operations are for x, I will get y. Once I have done my calculations, now I have an x and a y, so I can create ordered pairs. I want 5 ordered pairs in my table. Now, I only need 3 points to create a line, technically 2, but if you get only 2 points and they happen to be the wrong 2 points, there's really no way to check your work. But if I get 3 points and they look like this, I can look at that and say, well, I definitely know I did something wrong. But if I only do 2 points, there's no way to like visually look and say, hey, I did something wrong. Um, if I have 3 and it's like, oh, that looks like a line, that must be right. It might not be right, but it's a line, and I'm more likely to be correct here than I am here or even here, because that's only 2 points, and a third one might actually verify whether or not I'm correct. And so that's why we start with 5, and then that should leave us with having at least 3 that will work for what we're looking at. And then once I have my ordered pairs, I can plot my ordered pairs and then create a smooth line or curve. In our case, we're doing lines because that's what the section's on. But if you are going to be continuing on to further math classes, eventually you will look at some curves. I do want to emphasize this last step here because I do notice when teaching this class in the past that students forget to connect their points, and you have not graphed a line if you have not connected the ordered pairs. So make sure you connect the ordered pairs. So let's look at this. We have a table. I'm going to start by writing x and y so I can know what goes where. And the 5 points that I suggest starting with are the ones right in the center of our coordinate plane, which will be -2, -1, 0, 1, and 2. So that's where I always start. You could change it however you would like, but this is where I suggest starting, kind of in the center, and then making adjustments as needed based on what your equation looks like, or what kind of answers you're getting when you are getting your answers. And notice that my graph here is just kind of a basic, it's 10 by 10. I have 10 pieces every side. It's showing me the exact center. My graph does not always have to look like this. I can create a graph where the X and Y axis are off centered if needed, because my equation might need me to do that. So keep that in mind as well, that your coordinate plane does not have to be perfectly centered like this either. So once I have my X values chosen, each of these X values are going to be plugged in to the equation. So we have our first one is X is -2. So I'm going to replace the X in my equation with -2. Now this one is negative X, or the opposite of X, plus 4. So I have my negative from the equation, and then I have my negative from the 2. So I have two negatives here, which actually gives me 2 plus 4, which is 6. And that gives me an ordered pair. I'm going to do that for all of my X values. So I have the opposite of -1, which is 1, plus 4, which is 5. And then you can't really have a -0 because, 0 is neither positive or negative. But either way, 0 plus 4 is 4. And then we have, this time we have a positive 1. So it's negative X, or negative the 1, plus 4, which is 3. And then X is 2, which is 2. And so now I have all of my points, all of my ordered pairs. And I can graph them. Looks like my largest number is 6, so I'm actually going to add some tallies here to make my graph a little bit zoomed in. All right, so -2 and 6 is off of the chart. It'll be over here somewhere, so I'm not going to worry about graphing that one. I still have 4 points that will fit on my graph, and that's more than enough to create a line. So -1 and 5, 0, 4, 1, 3, 2, 2. And that looks like a line to me. Here's where I suggest pulling out a ruler and creating our straight line. And I'm fairly new to this digital ruler, so I've been practicing, but hopefully it worked. And then draw my arrows. Notice my line goes through and through. My coordinate plane starts on one end, goes through the other, has arrows on the ends, and that is my line. I have a couple of other examples I want to look at, specifically ones with fractions, where we might have to kind of do some special things too a little bit differently. The last one we had, these are all whole numbers. The math was not too difficult, but what happens when things don't always go out smoothly? That's what we're going to look at a little bit of the next two problems. So this next one, we have a fraction, and I'm still starting in the center here with these numbers, and I will substitute in for x. So 9 halves times -2 will give me -9, and -9 minus 5 is -14. That is too big for my grid here because my grid only goes to 10. If you have graph paper, and you can make your grid as big as you want. This isn't actual graph paper. If I had used graph paper, I could draw my lines wherever I wanted, but I didn't do that, unfortunately. Either way, or anyways, our next one here, we have 9 halves times -1, which gives us -9 halves. And 9 halves is -4.5. So then we have -4.5 minus 5, which is -9.5. So it looks like we're graphing a decimal, which is a half, not too bad. If you're trying to graph a fourth or a third or something like that, that might not be something we want to do, but a half's not too bad. Next one is 0. 0 times anything is 0, so this is 0 minus 5 is -5. And then this is 1, which is going to just make that 9 halves, which we said was 4/5. Or sorry, 4.5. So this is 4.5 minus 5, which will give us -1/2. And then if I multiply this by 2, the 2's cancel, giving me 9 minus 5, which is 4. Now I have, looks like 4 points I can graph because I can't graph this with my current grid. I'm going to leave the grid as is. I'm not going to zoom in because my largest number is -9.5. My grid goes to 10. So let's graph these. I'm going to go over to the left 1 and down 9.5. So this is 9 and this is 10. Halfway is 9.5. 0, -5. 1, 2, 3, 4, 5. And 1.5 would be here. And 2, 1, 2, 3, 4. Hopefully you all don't hear the train in the background. And let's see. I learned if I get it too close, it won't let me draw the line. There we go. And there's my line. This wasn't too bad. Even though we got some fractions, I could still graph it. But what if I have a fourth? Like my grid's kind of small. I could, if I'm dealing with fourths, I could design my grid so that I could graph fourths. You know, you could do that. Or you could choose your x values in such a way that you can eliminate the use of fractions. And we talked about eliminating fractions in chapter 3, and we focused on the denominator and your LCD when eliminating fractions. In this case, our LCD is 4. And so if we think about multiplying our fraction by the LCD or by multiples of the LCD, that will eliminate the fraction and leave us with whole numbers. And so I can create kind of a list of LCD numbers for myself, and we can use the positives and negatives of those to create numbers. Now, if you are using graph paper, I would suggest looking at kind of these numbers here, and then of course 0. I didn't write 0, but any of these numbers here would be good. Let's go with these 5 because those are within my grid here. So -8, -4, 0, 4, and 8. So 5/4 times -8 plus 8. These will divide out, which would give me -8 divided by 4 would be -2, which is -2 times 5 is 10, plus 8 is -2. And then the next one is -4. These just cancel, leaving me with -1. And so that's -1 times 5, which is -5, plus 8 is 3. And anything times 0 is 0, so that's 0, plus 8 is just 8. And once again, that the 4 and the 4, they cancel. So that gives me 5 plus 8 is 13. And this is already too big for my grid, so 8 is going to be too big for my grid. So I could solve to get that one if I want it, but I know that's going to be too big for my particular grid. But if you're drawing out your own and you want it to go, say, to 15 instead of 10, maybe you want to go back to the other end and do -12. And that way you can do extend your graph here on each side to accommodate and make it out to 15 and have enough spots. But -12 divided by 4 is -3, and -3 times 5 is -15. So that's -7. So now we have our ordered pairs. I'm going to leave my grid as is because I have my largest number is 8 and -8. So x is -8, -2, -4, 1, 2, 3, 4, +3, 0, and then 8, 4, 6, 8. And I can only fit 3. However, if you expanded it to be 15 by 15, you would be able to fit 5 points. And then I draw my line. And I now have a graphed line.